Welcome. In this session, I will discuss continuity of functions. We'll talk about continuity at a single number first, and this comes from a property that's generally true of elementary functions, namely the limit equals the value. Turns out functions with this property have other important properties as well. Two of them will be relevant to what we will do later. Let's start with the definition. We say a function f is continuous at a number c if the limit as x approaches c of f of x equals f of c. Note that this includes two specific requirements. First of all, f of c should make sense, so c should be in the domain of the function f. Secondly, the limit must exist. Only then we can ask if they are equal or not. So basic limit laws then amount to saying that a rational function is continuous at every number in its domain. Exponentials are continuous, and so are logarithms, of course provided that the base is appropriate. Combinations of continuous functions are also continuous. So if f and g are continuous at c, so are f plus g, f minus g, and f times g. F of g will be continuous provided it makes sense, that is, if the denominator is not 0 at c. In that case, the limit we know exists and equals the value if f and g are continuous. Compositions of continuous functions are continuous. More precisely, if the outside function is continuous at the value of the inside function, and the inside function is continuous at c, then the composition is continuous at c. So, what does continuity mean? Where does the name comes from? The name really comes from functions which are continuous at every number in some interval. If that happens, then the graph of f will be a single continuous piece with no holes, breaks, or asymptotes. Conversely, if the graph is a single continuous piece with no holes, breaks, or asymptotes, then the function is continuous at every point in that interval. We'll talk about properties of continuous functions after we discuss how to identify where a function is not continuous, that is, after we see how to find the discontinuities. I'll stop here and we'll talk about discontinuities next time.